No. So if you just got homework back, I'm still. Hey guys. Hey. Oh, yeah. If you just got homework back, I'm still grading some of it. So if I said okay, you're fine. You got 100%. It doesn't mean you were perfect, but just go through and see if you missed some. If I said correct, that doesn't mean like correct yet. It means correct the mistake. So anything I marked off as being wrong on another sheet of paper or on the same paper, if you can make it very clear to me what's new, correct your mistakes. Right? Don't erase any original work. Same thing with quiz and test corrections. Don't erase original work. If I said, I don't think I said redo on anybody or no credit. Redo is if you leave way too many blank or just so wrong, or no credit means you cheated and I could tell, and that's bad. Right? But nobody got that yet. Hopefully nobody. You know, somebody always does something. Is that cool? And you have until the day of the final to correct homework. I'd rather you keep up with new homework and correct it when you can, if you need to. All right. Is there anything else before we get back into 3-2? All right, so last time we learned about measure of central tendency, but in the interest of brevity, measure of center. We learned about two of them so far. We learned about the mean, which is kind of another name for average. And what symbol do we use for that? For a sample mean. I like it. So for a sample mean, it's x bar. And we introduced this notation here, right? The big sum, the Greek letter sigma stands for sum. Cool, I like it. And for the mean, it's the letter, who remembers what the name of this letter is?
Mu.
Mu, I like it. And it's really the same formula. The book uses a big S. Okay. So that's the mean. So here's population, sorry. That's population mean, that's sample mean. And we talked about the median, which is x tilde. Right? And the median is what? Yeah, it's in the middle when the data is sorted. Otherwise, it could be anything you want it to be. I like it. Cool. So, for example, what's the median of this data set? I like it. Cool. 13 divided by 2. You're just taking the average of the ones in the middle, right? So there's only 2 ones, you're taking the average up. So it would be in the middle of these two. It is in order, thankfully, so be careful. I might give you one that's out of order. In the middle of 4 and 9. And the way I do this is, how far apart are these? What's half of that? Go up by that much from 4, you go to 6.5. Or add them together. 13 divided by 2 is 6.5. So the median here would be 6.5. So how are we doing so far? And we talked about last time why these both exist. Some cases the median makes more sense, like income and salary. I heard those are the same thing. Income and home prices, right? Okay. So here's another one. These two are for what kind of data? Qualitative or quantitative? Quantitative. I have to actually be able to add them up. I have to be able to divide stuff. I mean, it only makes sense with truly numerical data, which is quantitative. Doesn't seem really fair. What about if I have qualitative data? I want to have some way of measuring the center of them too, to be honest, So another thing we use is called the mode. Right. Every time I hear about this, I want pie with ice cream. Mode, what does that mean? Yeah, it's the one that occurs the most. Mode is the one that occurs the most. So see, in that case, it could work with non-numerical data. So if I asked everybody what kind of car you drive, and most of you said Ford, then that would be the mode. of the types of car that people drive in this room. Does that make sense? Let's just go back to numerical though, just to make this quick. Let me give you a couple examples. So what's the mode there? Oh wow, yes. So, and there's no symbol for the mode. You could make one up if you wanted to. Picture of a pie with some ice cream. What about this? What about this here? Is there a winner? There's a winner. If there's a winner, that's the one. I know there's a couple twos, a couple fours, but there's 3 9s. That's the one that occurs the most, right? So the mode here is 9. What's the mode here? No mode. Nobody occurs the most. They all occur once. You with me? So far, so good? What's up? You all right?
No, I just said where.
Oh, here.
Oh, all right.
So this has no mode. Nobody occurs more than once, right? Those both have one mode. There's a clear winner in both.
What if there are only 2 9s?
I like it. Cool. Look at you reading my brain. Get out of my brain. It's not allowed. The test will be easy for you if you do that. So like that?
Triple mode?
Triple mode. We'll call it trimodal. So that would be, that's unimodal, or just bimodal, trimodal, and personally I say after that, screw it, there's no freaking mode, right? Sort of like in math, you got monomial, binomial, trinomial, and then they go, everything else is a freaking polynomial. Screw it. So I personally don't go above trinomial. The book calls things that are more than one multimodal, and it allows for more than 3, but 3 is like, come on. So this is trimodal. So the mode would be 2, 4, and 9. I like it. Cool. So that's relatively easy, right? Mode, most. Bam. And these all somehow measure the center. And you might think, how the hell would the mode measure the center? Like here the mode was 9. But that's not the center, and that's not what I traditionally think of as a center. But the center could be where things are clustering, right? You talk about, where's a good place to go downtown. You don't go necessarily to the very middle of downtown. You go to where people tend to be, the most people go, because that must be a nice place to go. That's like the center of the activity, right? So in some kind of data set, I could call the mode a type of center, because that's where it seems like things are clustering. Does that make some kind of sense? I think some of you guys are like averting dying days. You don't want to look at me in the eye. Okay. All right. That's not too hard, right? That's nothing too bad. Okay, good. And then we got one last one that's kind of like barely used, but I'll tell you what it is. Oh, somebody gave me a phone. So we got mean, median, mode. And then we got this weird little dude. Midrange. What do you think the mid-range is? Nothing to do with basketball. Sorry. What's the range? I think I said this really quickly earlier, but the range of your data would be the high minus the low, exactly. So the mid-range is the number that's in between the high and the low. I like it. So for that data there, this data right here, don't make me write it again. How would you find the mid-range? Careful now. I understand why you're subtracting. But to find the middle of two numbers, you take the... How do you find the middle of any two numbers? You take the average, right? So it'd be 9 plus 1 divided by 2. So the mid-range of that data would be 5. You guys think minus because range is high minus low. That's nice. Mid-range is the average of the high and the low. How do you take the average? You add. So that's the biggest mistake I see is people subtract for the mid-range. I understand why you're doing it. Just don't do it. Doesn't make sense. So again, that sort of gives us an idea of the center. Well, why is this kind of... let me see how to say this. So the median, the reason we sometimes use a median is in case what kind of stuff is in our data. Why is the median sometimes better? Why was it better for home prices and salary? Bless you. What kind of stuff was in our data for salary and home prices? Yeah, it's really extreme values. It could be really, really high stuff that would kind of throw my mean off, so the median is more representative, or really, really low stuff doing the same thing. You with me? So the median works well because it doesn't take into account the values. But that's the same reason the mean makes more sense sometimes. The mean takes into account all the values, so it's more of a robust meaning of center, the center of the data, and taking them all into account. The mid-range only takes into account the highest and the lowest. Right? So again, it doesn't take into account all the data. So the one that we use the most is the mean. That's the one that kind of wins out this war, understanding that there still are little battles that we want to use the median for. And then the mode is good, especially if I only have qualitative data, like types of cars. That's the only one that would work with qualitative data. And then the poor little mid-range dude, you don't see him much. All right. Cool. So that's the 4 types of center that you'll see in section 3.2. The mean is what we're going to use most often going forward. Okay. Blah, 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 blah. Oh, good. That's it for 3.2. I like it. So any questions on that before we get into 3.3? 3.3 is the main heart of today. Today what we're going to do is the statistical equivalent of watching sausage being made. We're gonna make a formula. So that's one reason why I like statistics is you can get in there and just say, I want a formula that'll do this. Let me just make it do that. Obviously, that's already sort of been done. So I kind of got to guide us to what's already been done. But I want you to make sure it makes see that it makes sense how it got put together. So what I want to do today is talk about something called standard deviation. That's section 3.3. 3.3 is a little bit more broad. It talks about measures, what did it say, variation? Yeah, good. So let me give you a couple of like real nice real life examples of why I want to know something more than what the center is. So you're all aware. All right, let's start like this. You're all aware there's a website that you can go and see what people think about teachers, right? And I remember the first time somebody said something about this when I was teaching on the East Coast. The next day, if you went in, you could see all these teachers who had rated themselves. It was hilarious. Somebody wrote the essence of the essence. I'm like, you're a dork, right? So there's that website, right? There's also a website that a lot of you don't know exists, and you actually have to pay for it, thank God. But it's public domain knowledge. You can actually go and see the grade distributions of teachers, what kind of grade they've given in all the different kind of classes they teach. You with me so far? Do some of you guys know that exists?
What's it called?
My.edu. My.edu. Thankfully, you got to pay some money. It used to be free. It's too bad for you. You missed out. Right? And of course, unfortunately, real quick PSA, public service announcement. People go on there, they find a guy that gets nothing but A's, and there is a stats teacher who does that. You didn't pick him. Sorry for you. And then you don't know shit. Right? So I had this poor guy who wanted to tutor stats. I remember a few years ago, really smart kid, knew math really well, but he couldn't tutor stats for shit because he took this guy, so he didn't really know. Tests were like fill in the blank, and some of you guys are like, who's this guy? Is there a room? No, there's no room. Everybody went there. There's been no room forever. So give up on that. But anyway, I'll get past it. If I went to that website, and let's say there's these two teachers who, in every respect, is the same. They're like clones of each other. So there's nothing else that would be, except for the grades they give. They both give an average of C, right? In fact, I'll say they both give exactly an average of a 77. Doesn't even matter. You with me? One of them, we'll call him Jim, gives B's down to D's, and that's it. Right? And let's pretend we're at university where D actually is passing. Here, you need to make a C to actually have a transfer. You with me? But if you're at university, make it D and still go for the next one. Just don't be my guy. Right? So this guy gives nothing but B, C's, and D's. You with me? So I've given you an idea of the spread of grades. If I just tell you their average grade, it's not good enough. What's another way I can have somebody who has an average of a C? They give nothing but C's, no matter what. You with me? So that's one extreme. Then I could have somebody that gives B's through D's, and then of course I could have somebody that gives every grade under the sun. All right, how we doing? And I have had a teacher that I think they were waiting for some kind of a God to come down and take their class, because he never gave A's. I got a B plus in that damn class. Sorry, it's still a sore point. And even God would have got a freaking A minus. God. This guy, sorry. All right, so you with me? So I got one teacher that gives, let's say we got three. We got one teacher that gives nothing but C's. It's all he ever gets. Then we got somebody that gets B through D, and then we got somebody A through F. Why is that information good to know? If you think you're going to suck desperately bad in this class, who will you take? The one that gets nothing but C's, right? If you think there's a chance you might do all right, you might do the B through D, because then at least then you have a chance to get a B. Because what sucks about the C guy? What if you know you're going to do really well? You're going to kick ass in this class, and you got a guy that gives nothing but C's. Ain't no way I'm taking that guy. You with it? And if I think I'm going to kick ass, I'm going to take the person that gives A's through F's, because I'm going to make the damn A, right? So the information, I want you to understand, what was important here was they all gave a mean of C. But that wasn't good enough to discriminate between the three of them, to really differentiate. And once I told you the spread of their data points, then you can make better informed decisions, right? In fact, I don't even have to show you all their grades they've given over the last several years. I just have to tell you two things. What's the middle and what's the spread? Two things, and then I can make all these decisions based on that. You guys semi with me? So throughout this course, when we learn a new way of presenting data, we're going to at the same time learn a new way to calculate the mean and a new way to calculate this thing that we're about to talk about. It's called the standard deviation. Those are the two quickest ways to summarize a set of numerical data, is to calculate those two things. All right, so here we go. So what I want this measure to do, this measure of variation, this standard deviation, what I want it to do is to tell me how spread out my data is. So let me give you three data sets. It's like the guy that gives nothing but C's, right? Then we'll do, let's see, what do we do, Jeff? That's a person. And then we'll do do you notice how I put them together? What's the mean of each of those? 3, right? Because if I take that down by 1 and that up by 1, it's still an average of 3. You with me? In fact, real quick, let me go take you through this. I always tell my algebra students this. If I know that 5 numbers average to be 3, what do they have to add to be? The only way that 5 numbers can average to be 3 is if I add them up and divide by 5 and get 3. So they have to add up to be 15. Because what do you divide by 5 to get 3? 15. So if I told you 5 numbers average to be 3, do you know what those numbers are? No. Could one of them be 100? Yes, because maybe another one's negative, right? As long as at the end the sum comes out to be 15. So obviously this mean is 15. So how do I make sure, the sum is 15, the mean is 3. How do I make sure this mean is 3? If I take one down by 1, I've got to take another one up by 1, so it's still the same sum, right? And of course here I took this one down by 2, that one up by 2, so forth. All right, I'm done with that. Just want to see, when you think about average, there's a little bit more you can do with it than you sometimes realize going in. All right, so the mean for each of these, and actually let me do this. We'll do this whole discussion as if they are each populations. And sometimes students think that a population has to be big, and normally it is, but a population could consist of 2 people. In this case, it consists of 5. So I'm going to use that symbol because that's the symbol for population. So the mean in each case is 3. Now, a decent idea for what to use for the spread is the range. What's the range for the first guy?
3.
Yeah, what's the high minus the low? 0. What's the range in this guy? 2. And the range in this guy? So the range does discriminate between all 4 of them. But let me give you one more set of data that's going to blow the range away. It's not going to be good enough. Let me see if you guys answer me correctly. This will help us along if you do. You come with 3. So the mean here is 3. What's the range? 4. It's the same as that range, right? Are these two the same in how they're distributed? Which one has a larger variation? Which one varies more? Yeah, this one varies more, right? Let me let that sink in. I want the number that I'm going to create a formula for to tell me how spread out my data is. So that number has to be different for these two because this one is more spread out than that one. Is that true? So whatever this number is, it better be different for these two. So can the range be that number? No. Because the range sees them both as being a range of 4. It's not good enough. All right, let me stop there for a second. You're all at least looking at me. That's good. Does that so far make some good sense? I like this. Keep going. All right. I love it. All right. I desperately want this to make sense. Yes, ma'am.
How did you get the, I don't get the ranges. I don't understand what you're doing.
So the range in general is what? High minus low. So on the first one, the highest is 3 and the lowest is 3. So the range is 0. I like it. So it kind of tells you how far your data range is. This never goes away from 3, so the range is 0. This goes from 2 to 4, the range is 2. I like it. But the range is not good enough for this other number I want to find because it doesn't discriminate between these two. Maybe. These two should have a different number. This is more spread out than this one. Why is this more spread out than that one? Not just because it repeats 3. More importantly, let me see how I'm going to guide you a little bit. I have to. But I want my measure of spread to be based somehow on my center. Why is this one not spread at all? Because it just stays right on the center. Right? This one's a little more spread out because a few of them get away from the center. This one's a little more spread out than that because they get even further away from the center. And this is the most spread out because more of them get away from the center. So it seems like this number has to fundamentally be based on the distance from the mean to each data point. Let me say that again. It seems like the number I'm trying to create has got to somehow be fundamentally based on the distance each data point gets from the mean. The further they are on average from the mean, the bigger this number is going to be, because that's like big variation. You with me? That's why this is so low. This standard deviation should be 0. And whatever this standard deviation is, it should be a little less than this one because this has more variation. Okay, I'm trying to let this sink in. All right, some of you guys are at least humoring me. I like that. Sure, man. All right, so what I'm about to do, I'm going to step through the process of creating this formula with this one. This one is semi-boring, so I'm just going to forget about him. If we apply what we're about to do to him, the answer is going to come out to be 0. All right. So let's do that one, and then I'm going to make you guys do this one using what we do. All right, here we go. So the way I want to write this, let's write this, we're going to work with this set of data here. Let's write this in a chart kind of way. And let me say this right now, because as we go through this, some of you guys are going to be a little worried. After this first test, I will never make you do what we're about to do right now. What we're about to do right now is something I'm going to make you do a lot. If you don't do it in your homework, I'm going to make you do the homework again. Some of you guys know there's a button on your calculator that'll do this all for you like that, right? If you use that only, your calculator passes the course, you're stuck, right? It's not a good way to be. I'm pretty sure your calculator can pass the course. But my promise to you is I'm never going to make you do all this after this first test. After this first test, we're just going to get this number from a calculator and then do other stuff with it. You guys kind of with me? I want that in your head as we do this. You go, oh shit. And no, this is for the first test. Because this is a little bit of an involved process. So let me say, what did I say this had to be based on? Since it's all about how far away we get from the mean, this has to be based on the distance away from the center to the data points, right? So of course, to find distance, let me not say different, let's say difference. Yeah. To find a difference, I use subtraction. So it's got to somehow be based on this idea. And this by itself, we call that a deviation. It's how much a data point deviates from the center. So if the average income at a company was $48,000 and you make $50,000, your deviation is $2,000. That's how much you are away from the middle. All right, good. I like that. All right. So what is the mean again? 3. Yeah, the mean for all these was 3. Oh, let me use the right symbol. I keep forgetting I'm in a... Why did I put X bar there, Jeff? So this is X. These are my values for my data points, right? That's X, just like in algebra. Then I want X minus the mean, the mu, because I'm calling these populations. We're going to have to make a little adjustment for samples. So that's why I wanted to do population first. So what's this one going to be? 2 minus 3? Negative 1, 3 minus 3. That's crazy. 4 minus 3. All right. The calculations themselves are pretty easy. I'll show you how to do all this work in your calculator in case I give you a much longer list of data, which you know I will. Right? Not crazy long, because then that just becomes busy work. Now, what's wrong with this? So let me say what I said earlier, but let me make sure you really hear me. This number I'm trying to create, I want it to be based on the distance from the middle, from the mean, and I want it to be an average distance from the mean. Let me let that sink in, that phrase. The average distance from the mean to all the data points. Wouldn't that be a measure of how spread out they are? So that's why this would have more than that, because on average, the data points get away from the mean more often, right? Do you guys see that? So this guy should have a bigger number than this guy. A little bit.
Why?
Because which one of these gets away from the mean more often? This one. So the average distance from the mean to each data point for this one will be a little bit bigger than that one. And we want this number to differentiate between if it's spread a little bit or spread a lot. I want it to differentiate between those for me. All right. I know some of you guys are thinking, I don't want that. That's too bad. You're in this class, you're going to want it. What's wrong with this, though, if I try to take the average of these, and some of you guys already know what's going to happen here. If I try to take the average of these, when I add these up, I get 0. In fact, I don't care what my data looks like. This column will always add to be 0. Because what's true about the mean? It's in the middle of the data somehow, right? It's got equal numbers. So if I subtract the mean from every data point, there will be equal negative to equal positive. They'll always cancel out. So far you're like, good job, Jeff. Thank you for that. Bringing us down this dead end is always freaking 0. So the sum, let me show you this. Let's get out of there. You see that little phrase there, the little math phrase? Based on our conversation last time, does that make sense? Because if I add these up, I'm adding these up. I like it. Some of you guys are like, yes. This is true. So one thing I could do to this, some of you guys, what in math, we're not going to use this, I'm going to tell you why, but in math, what do we use for distance? What function gives us true distance? No. So a function that tells me 2 is the same as negative 2 because they're both 2 away from 0. What function is based on distance? It always comes out positive.
Absolute value.
Absolute value. So that's why absolute value comes out positive, is because it's based on distance. I don't know if you knew that. Your teacher should have said that, because that's why it's always positive, right? Makes it real easy to remember. I could use absolute value, but what sucks about absolute value, this is not quite the whole story, but this is enough for right now. What sucks about absolute value is, what does it look like if I graph it? Who knows that? Be very specific. What letter does it look like? V. Parabola looks like a U, which is better. So a V, what sucks about a V? Would you want to be in an airplane that did this? Right here, you die. You're dead. Right? You don't want to make that sharp turn. So in math, there's a lot of, at a kink, there's a lot of weird shit that happens. It just totally changes quickly. We don't like that. So instead of taking an absolute value, which would work, and you could use that, and that's called the standard error. But it's not used as much as what we're doing now. So you could use absolute value, but it leads to some math problems later related to how sharp of a turn this is. So instead of absolute valuing it, just to make a verb out of that, what's another way to make it always positive? That has a nicer graph. Square. Because then I got the plane coming in, and it makes a gentle turn, thank God. Right? So that we don't all die. I still wouldn't want to be on this plane, but I'm not dead if I am. So then I do this. And again, let me ask you this. Why do we square that? Because some of the stuff's negative and it would make 0. So I don't want that to happen. Absolute value I don't use. This is not the whole story, but a lot of it has to do with that big kink in the graph of the absolute value. So I get 1, 0, 0, 0, 1. So what's the sum of x minus mu squared? 2. I love it. Please tell me, is it cool when I write this? Do you totally understand what's going on there? Right, if you just cover the sum symbol, it tells you what column you have to make to do this. So if I need this in an equation, I need a column of those. We made a column of those. Cool, now I can add them up. All right, good, good, good. Possibly. Okay, okay. Come over here. Let me not kill myself. All right, so now let's put this thing together. So what I want to do is I want to take the average squared distance from the mean. Now what am I going to have to do at the very end, considering how I got rid of the negatives? I'm going to have to take a what? Take a break. No, I'm going to have to take square root. I got to kill the squares that I did. Does that make sense? So I squared to kill the negatives. At the end, I better square root. Because right now, this could be dogs, right? The number of dogs people own in my neighborhood. So this would be 1 square dog. What happened to this dog? Today's not a good day to be a puppy in stats class. We didn't give you water, and then we compacted you into a little box. Right? So I better at the end square root so they make freaking actual real life sense. Don't have a freaking square puppy when I come over. Have a normal puppy. All right, maybe. Okay. How do I find the average of anything? Average of anything. What do? Add them up. Divide by how many there are. I love it. So if I want the average of these, and we already did, didn't we? So to find this, to find, as I go through my third puberty, this is the pre-square rooted thing. That's why it's got a little square on it. Is that cool? This is before I've taken a square root. I'm going to do that at the end. So this is not quite the standard deviation yet, because I still got to square root it. This is called the variance. And right now, all the variance means to us is we're not done. We got to take square root. Later we'll look at the variance a little deeper, but right now it just means you ain't done yet. But the variance is going to be the average square distance. So it's going to be the sum of all these distances, squared, divided by how many there are. So that is the general formula for finding the variance of a population. How do I know it's of a population? Because it's got mu in it. I like it. Yes, sir.
What's that first, I don't know what it is, like squared?
Oh, I like it. I'm sorry. I forgot to tell you what it is. It's the lowercase sigma. Believe it or not.
Lowercase what?
Sigma.
Oh, like the E thing?
I love it. E thing. It's the lowercase e thing. Right? E thing sounds like the next freaking tablet you want to have. You got E thing. All right, sorry. Maybe. And so the standard deviation incredibly enough, the standard deviation, it'll be after I take a square root. Is that cool? So after I take a square root, so its formula is just going to have a big ass square root around this bit. So the variance is kind of like a middleman. We give it a name because actually later we'll find out there are some things that's important about it. But right now it's just, well, you haven't taken a square root yet. So the symbol's reminding you, dude, there's still a square on this thing. You got to take a square root. So let's figure out what it is for this data here. Let's actually do it for this data. So for this data, the variance, what do I put on top there for that formula? 2, right? Because that's the sum of that. You don't ever plug stuff into here that doesn't make any damn sense. This means you already have a bunch of these and you're going to add them up. So don't try to plug stuff into that. That wouldn't make any sense. Somebody's going to do that, right? Don't really blame me too much because you do that all the time in algebra. But this is a single number that you got to figure out and then put it in there. So here we get 2 over 5, right? Because there's 5 data points. So that's the variance. And 2/5 is what? Is the decimal. What's 2/5? 0.4. Thank you. And so what is the standard deviation? Somebody help me out.
0.63.
Sure, man. So you just, yeah, okay. Yes, sir.
How do you get the 5?
Oh, how many data points do I have? Yeah, because how do you find the average of anything? You add them up and you divide by how many there are. And there's 5 of them, right? Cool. So the formula is add them up divided by how many there are. So I really want you to realize the standard deviation is an average this. So it's an average distance from the data point to the mean. That's exactly what we said earlier. You can actually see the idea of it in the formula. When you add something up and divide by how many there are, that is the average that. So standard deviation is the average distance from the mean to the data points. And that's exactly what we want it to be. We wanted it to be that, to see how spread out the data is. All right. I have talked way too damn much, and some of you guys agree with me way too much. But I want you to do everything we just did for this data, the most spread out data. So how should its sigma compare to this guy's sigma? It should be bigger because it's more spread out. Kick ass. Do it. Figure it out. If you know how to do it in your calculator, that's nice for you. Do that. Yeah, I like it. I like it. Oh, see here, that's the sum of those. That's exactly what this is. So that 2 is in place of that. No. You're not supposed to plug anything in here. You're not supposed to plug anything like in. What's this whole thing? It's 2.
Oh, okay.
So you replace this whole thing with what it is. And then of course n is just the number of the And the last one is
What happened?
when you're cool
No, I didn't know how you got those numbers. Negative and 0, 0.
Okay, it's take the x. So this is including here. And take the mu, which is 3. Minus 3. So 1 minus 2 was 6.
Oh, the window?
No, no. Take
1. Where's this 3 at? This one here?
this 3 is the right there. See how the right there in that one? It's the mu.
Oh, the U, yeah, right.
What is 1 minus 3?
2.
We do 2
2 minus 3. 1.
Oh, into the heat. No, the whole expression
Minus
is.
4 is -1.
Yeah, so 5 too.
Oh,
So even the algebra we do isn't the algebra we use.
oh, that's right.
Would it be? Would it be that?
2 over 5, 0.4.
You have to do the next.
Yeah.
I did the,
Did you do the next line over?
Oh, that's what it is. Hey. Yeah, sorry. Square. 4.
yeah, and then just square.
I did that wrong.
No, it's 2 No, it's 10 to 5.
Just 2 others.
The square. The square is like 2.
Yeah, I got 10, and then you divide it by 5. Oh, it's 2. Yeah, oh my gosh,
Then you take the square root.
yeah, that's what, oh my gosh.
That's why I was like,
Yeah, no. Yeah, I did the square root of 5.
So this becomes 4, right?
Okay, 1.4.
1 and 4.
yeah, 2 squares.
So the total is 10? This is 0 here, right? Because and then over here, the variance is
But you don't need to do that. You can take 4.
You just add them all. It would be 2 more. Add these up.
I'm sorry, you take this one.
Good. Square. So what's negative 2? Up there, it was kind of square negative 1. You truly square.
That's the sigma, lowercase sigma. The T or whatever you call it.
So what happens if they...
You don't, you already did it.
So that will...
You don't want to, I believe you don't want to ever put it in the plug.
Oh, yeah?
You don't want to just plug it here. You want to figure this out, then, because you're not going to put these numbers in here.
Oh, you don't, you just basically,
I mean, I'm sure you can plug it here.
All right, guys, so let me catch up to you. The mean here again was, of course, 3. All right, all of them had 3 mean. So what I put there? Yeah, 1 minus 3, negative 2. Negative 1, 0, 1, 2. Oh, well, I guess I got one color today. And then here you got to really square it. The negative 2 squared is 4. Now, the part that's weird, and I like the questions I was hearing about the various parts of the formula. Statistics formulas very often, not all the damn time, you're going to replace entire parts of it with a number, especially when it's got a summation symbol on it. So when I add these numbers up, what are these numbers? These numbers are this, right? So this here is a process. It's not quite what we're used to. It's a process. What does it say to do? Put the number here that you get when you add these up. That's what that says. So it's not substitution in for x and mu. It's substitution in for the whole damn thing. It's what you get when you sum the stuff up. So what do I get when I sum this up?
10.
I highly recommend you actually tell yourself what the hell it is you just did. I added up these so that then you can find it in the formula very easy. If you just have a number sitting there, you're like, got a number. So we got 10. Then that's going to go here, right? That's the sum of these is 10. So 10 is going to go up here. What's n?
5.
Still 5. So my variance is 2. Standard deviation, I just take
Square root of 2.
square root of 2. And you get
1.14.
And I'll tell you this, let me go ahead, I was debating how to do this because the book uses something a little different. I'm just going to do this still. I have my own reasons. Always take standard deviation out at least 3 places. You with me? At least 3 places. So there's never any question. You never ask me. It's just always at least 3 places. You guys with me? So don't make it 1.4. Don't make it 1.41. Make it 1.414. 3 places. Cool. I like it. And real quick, if your standard deviation came out to be this, I don't mean 3 places like that. I mean 3 places that aren't zeros, right? So you'd actually write all that 192. Don't make it 0. That's not really telling the truth. That would mean everything's the mean, and obviously not. There's a little bit of variation. Well-placed eye. I like that. All right. So let me give you this. Here's the last thing I'm going to make you guys do. Actually, let me show you how to do this in a calculator because you'll need it because I gave you a lot of data. Anytime. This one didn't work, right? For the
It worked for the calculator part. It didn't work for the
overhead?
projector. Yeah.
Okay, good. Thank you.
Oh, yeah.
So if you all work with me, we can get out decently early. Don't get used to it. I just feel like letting myself out early. So if you help me out, we can do that. I like to be honest. All right, guys. So if you need to borrow a calculator, if you want to play along, here's some here. Please make sure to give them back to me.
Clear the data first.
Guys, just to remind you guys, you want to, I don't think I printed this out for you, right? I'm trying to conserve paper. So if you want to, there's what I used to call the calculator Bible chart. It tells you basically part A here is what we're doing today. Part of it. Actually here, part B, sorry. Part B. All right, so if you want to go to my website and print that out for yourself, you can use it for homework, but you can't use it on tests. So don't even ask me. You're good?
Yeah.
All right. All right, so here's what I want you to do. So if you have a calculator, go ahead and clear out list 1. Remember, to clear it out, don't hit delete, or else your list goes away. It gets sent to the cornfield like the old Twilight. Hit clear, enter, and then go ahead and put that 1, 2, 3, 4, 5 in there. We're going to double check that work we did. like always, when I'm doing this calculator thing, tell me immediately if your calculator's freaking out or if you're not sure what the hell's going on.
You have to do it in the stats.
So what do you think I want to do with L2? What do I want in the second column? I want the second column to be all of these minus 3 in this case, right? So here's what's really cool. If you go to list 2 and then watch, highlight L2. You see that? Highlight L2. And then you can tell it what L2 is. And I want L2 to be, now where are my X's? L1. So I want L2 to be L1 minus 3. All right. I'll do it again. Hold on. Sorry. So I want L2 to be X, and all my X's are in L1. So I want L2 to be all the L1 stuff. Second one to get L1. See that? Minus 3. So that's X minus the mean. And so you should get the -2, -1, so forth. Let me do it again. Some of you guys had that look in your face like, do it again. So highlight L2, and then you can define the entire list. You say it's L1 minus 3. Because that's L1 is where my X's are. Minus the mean, which is 3. What are you doing so far? Good, okay. And then what do I want to do with L3?
L2 squared.
Now watch this. If I make a mistake, am I in the right place to do L3? I should have L3. If I stay here, watch what it tells me. L2 squared. What the hell are you trying to do to me? It says data type. I'm trying to put an entire list into one spot. So of course the calculator's like, can't do that. Say go to. Say, oh shit, I'm in the wrong place. Go up to L3. L2 squared. And of course there's my 41014. Right. So far so good? Okay. Now, hit second mode to get out of there. Because what do I want next? What do I need for my formula? I need to do what? I want the variance issue, but to get for the formula, what do I have to do? Add these up. So I want to add up list 3, right? This is all on that calculator procedures. So if you want to, go print that out. We're going to do it right now. You ready? So going back in for a second, I want to add these up, right? Because the formula needs the sum of those. Let me get out of there. You see above stat where it says list? And you see the math? So I can do stuff to my lists here. Go to math and I can sum. Yes, sir. Sure. Alright, so if you're in the list, if you're ever anywhere weird, like you got big old thumbs, and you're like, how the hell did I get there? Hit second mode. See the quit? Quit means get me out of this. Right? So if you're in your list, hit second mode to quit. Now I'll go to second stack to get to my list stuff. Go to math. And I want to sum. How are we all doing? Is everybody with me in the same place? So I can hit the number 5 to get sum. And what do I want to sum? L3. So they hit second 3 for L3, right? And there's the 10. Now, just in case anybody's thinking this, there ain't no damn way I would do all this shit for 5 numbers. Right? That way I have to just do it by. But if I had 20 numbers, I might be thinking about doing this, right? Okay. And now you can plug that into your formula and so forth. Let me show you this shortcut. You ready? This is what some of you guys already know. I'm going to show you the calculator just spit the answer out at you. So you can at least check your work. If you go to stat, how many variables are up there? 1. I love you. No, enjoy the answer. So there's only 1 variable. There's 5 values, but there's only 1 variable up there, right? Like I said, it could be the number of puppies somebody has or whatever. You with me? And they're giving them water somewhere. So if I go to stat calc, see calc up here? One variable statistics, because I only have one variable. Later in the course, we'll put two variables in there. It could be the number of beers you had last night and the grade you made on your early morning exam, right? That would be two variables. We can do stuff with them. Yeah, actually, that's the one we do. Well, we don't drink. Don't drink if you want to, just not because I said so. Go to number one, we're in trouble. And it defaults to list one, and that's where my data is, right? List one. If my data was in list two, I'd have to tell it list two. You just hit enter right now. Does anything look familiar? Anything look familiar?
That's the answer.
Yes, all right, good. So one thing I noticed is there's 1.414. And what's that sitting next to? What's this symbol here? That's lowercase sigma, right? That's sigma. Now say sigma x, because if I had two variables, there'd be sigma x and sigma y, so it can differentiate. You guys kind of, I only have one variable, so it's saying sigma of what you plug in. What's this? This is if it was a sample. If it was a sample, I actually use the letter S. So for mean, mu is population. Greek is always population, like Super Bowl excellence, right? And then X bar is the sample mean. Sigma is the population standard deviation. S is the sample standard deviation, right? So the calculator has no freaking clue what the data is to us. We have to pick the right one. And like we said going in, this was a population. So that's why that's the right answer there. Oh, we do it again. And of course, what's the first thing? The mean. It's always going to use this symbol, even though we know it's a mu. It's just going to give me that symbol because, again, it doesn't know. Right? And that's the sum of x squared we talked about before. Remember that? If you scroll down, you see some more stuff, and we're going to talk about that yet. So to do this again, you go to stat calc, because now I want to calculate something with my variables I put in, my data values. One var stats, because I only have one variable in there. I just hit enter because it defaults to list one. If I have my stuff in list two, I've got to tell it list two. And then there's the list. Yeah, because that's where my data is, right? The other lists were me doing shit with my data. The first thing is my data. All right, so let me give you this. Let me see if we can do this. Yeah. One side of this has a completely worked out problem, so you can kind of reference it. And the other side is what I want you to do right now. And the sooner you get this done, just do 40. The sooner we can go wherever we like to.
I guess that's kind of
Like I said, one side has a completely worked out problem. Focus on just doing part A and B for now. We'll get that done today together, and then we'll do the rest of it next week. So focus on getting the mean, the variance, and the standard deviation. Don't worry about the rest of it yet. No, I almost forgot. Let me say something real quick. I forgot I did this. So for the mean of a population, you got the little mu. If I'm working with a sample, let's see if I can explain this relatively quickly. So for a population, here's what the variance looks like. Right? The sample, I've got to adjust it a little bit. Let me see if you guys are with me real quick. There's an average age in this classroom, right? If I pick a sample of you guys, will that average age be the same as the true average age? Probably not. Are you guys with me so far? If I take any sample of you guys in the first row, and I take an average age, it's probably the same as the real average age of everybody. So the people's ages in the row I pick will be closer to their mean than they would be to the real mean. Does that make sense? Because their mean comes from their ages, right? So to adjust for that fact, that the standard deviation for a sample will always be smaller than it really should be because their data points will be closer to their mean. To adjust for that, I don't divide by n, I divide by a little bit less, so I make it a little bit bigger. I divide by n minus 1. So that's why the formula on this page has, for a sample variance, I don't divide by n, I adjust it a little bit, I divide by n minus 1. N minus 1 is going to come up a couple times in this semester. I can't get too deep into the real, true math story behind this, but that actually is basically the real story. Why is it exactly n minus 1 that works? That's what I can't really get into. But it is just an adjustment because it's a sample. So everything else is exactly the same. And that's why the S is a little bit different than the sigma. Okay, yeah. I just forgot that I made this one a sample.